Okay, so now it's time, and maybe I will just start the session while we're waiting for other people to join. Good afternoon, good morning, members of the audience and special guests. Welcome to this V dialogue session. And my name is Mu Yang, and I'm the Deputy Secretary at the International Society for Energy Transition Studies. It stands for ASSET. And ASSET is a non-profit organization established in 2020 by a group of 31 energy professionals. It now has members in over 40 countries and more than 10 international organizations. ASSET seeks to help facilitate an equitable and inclusive transition of energy and other relevant sectors towards a sustainable and clean future. One of ASSET's key objectives is to provide a platform for multi-stakeholder dialogue and debates on issues related to energy transition. And the Way Dialogue session today is one such platform. If you want to explore more about our activities, more details are available on our website at asset.org. Today, we are joined by Professor Richard Tom to discuss the social cost of carbon. Questions are welcome at the end. So please remember to submit your question using the bottom panel of this Zoom webinar. I think there should be a place where we can submit questions. Now, a little bit about the speaker, Professor Richard Tom. Professor Richard is a professor at the Department of Economics, University of Sussex, a professor of the Economics of Climate Change, Institute for Environmental Studies, and Department of Spatial Economics. And he is also a professor at Vrije University, Amsterdam, the Netherlands, and a research fellow of the Tinbergen Institute and the Payne Institute for Public Policy. His research concentrates on the economics of energy, environment, and climate, as well as integrated assessment modeling. He is the editor-in-chief for Energy Economics Journal. He is also the author of the only textbook on economics of climate change. He contributed to working groups 1, 2, and 3 of the Intergovernmental Panel on Climate Change. And he is also a shared winner of the Nobel Peace Prize for 2007. So welcome to Professor Richard. I will now hand it over to him to begin his presentation. Thank you, Professor, and the floor is yours.
Thank you. It's an honor and pleasure to be here, if only in silico. It is a fairly small group, so I wouldn't mind if you had questions during my talk. The topic of today that I thought I'd talk about is a partly new, partly old subject of mine. I'm going to talk about the social cost of carbon, which I have been doing for a while now. But I'm going to try and answer the question, how would or should the government of China estimate the social cost of carbon? And that is a topic that is fairly new, and I would really appreciate your feedback. You know in China much better than I do. I'm going to First, I need to wake up my computer. There we are. I'm going to cover a fair bit of ground. I'm going to go fairly quickly through things. I'm going to talk about the total economic impacts of climate change, social cost of carbon, obviously, then its sensitivity to ethical choices. And once I've covered all that, I'm going to turn the attention, that is the new part, to a social cost of carbon for China, and ask the question, how would a Chinese social planner look at these matters? So that is the plan for today. And let's just jump right into it. There are now 39 published papers that estimate or claim to estimate the global economic impact of climate change. The total economic impact of climate change. There's many more papers that look at economic impacts of a particular sector in a particular country, but there's 39 that claim to look at a global total. And then there's another 11 papers that estimate the impact not of climate change, but of weather shocks. And this is what the 39 papers say about the global economic impact. The problem I'm having is that when I interact with Zoom, my computer takes away its attention from PowerPoint. Okay, here we go. So what you're looking at here is a fairly complicated picture with lots and lots of information. I won't take you through all of it. On the horizontal axis, you're looking at scenarios of climate change. Here, indexed by the change in the global mean surface air temperature as an indicator for the severity of climate change. And then on the horizontal axis, on the vertical axis, sorry, we're looking at the Higgsian equivalent variation. So essentially what this says is that if the world were to warm by 2.5 degrees, then the average person on the planet would feel as if she had lost 1.7% of her income. It's not saying that she lost 1.7% of her income, but she would feel as if she had lost 1% of her income. This is a welfare measure, not an income measure. And 1.7 is the average of the dots here. Now, all the dots that you see are different primary estimates. The literature uses 4 roughly methods to estimate the total economic impact. The oldest and perhaps the simplest one is the so-called enumerative method. And what you do there is you look at the physical impact of climate change, or you look at estimates of the physical impact of climate change. So that would be changes in crop yields, that would be land lost due to sea level rise, and that would be the number of people dying prematurely because of health risks of climate change. And then once you have these estimates in their physical units, you also then estimate a price, which is sometimes easy. Crop yields, you just look up what is the price of these crops. Sea level rise, you look up, you call up an engineer and ask them what would it cost to raise the dikes by so and so much. But for other impacts, particularly impacts on nature and on health, you use monetary valuation methods, the ones that have been developed in environmental economics more broadly over the last 6 decades or so. Once you have then estimated the prices as well, you just multiply price and quantity and add them all up. It's a direct cost estimate. So that is one method. Another method is to again take these physical impact estimates, and instead of directly valuing them, you translate them into shocks to the economy. So people dying would be a shock to the labor supply and an increase in the demand for healthcare. Building dikes along the coast would be an increased demand for construction, and so on and so forth. And then you put them into a computable general equilibrium model, a model that covers all the trade flows in all the markets, input markets as well as output markets across the world. And then shake the model and see what happens to welfare. So those are 2 methods. Another method is to use econometric methods to see how land values change with climate, or to see how self-expressed happiness changes with climate, or to see how consumption patterns change with climate. And all that is over space, and then you assume that this relationship also holds over time, and you use this econometric method to project the impacts of climate change. And the final thing that people do is just go around and ask experts what the impact would be, and then sort of assume that these experts know what they're talking about. Now, so that is what you see happening in this graph. There's all sorts of methods. The elicitation methods, the ones that I mentioned last, are the most pessimistic. The econometric methods are actually showing positive impacts of climate change fairly far into the future as well. Some people are surprised by the fact that there may be positive impacts of climate change, but that is a bit peculiar because, I mean, it's a change. Why would a change be necessarily bad? Change may be good as well as bad, depending on what the change is about. The positive impacts of climate change that we see are the main ones are threefold. First, if it warms, winters will warm as well, actually a little bit faster than summer, and that means lower costs for heating buildings and homes. That is one positive impact of climate change. Another positive impact of climate change is that milder winters will mean fewer cold-related deaths. That's actually a fairly big one. And the third thing is that CO2 is plant food. If there's more carbon dioxide in the atmosphere, then plants grow faster and they become more drought resistant. And those are actually the main positive impacts of climate change. In the long run, as you see in this picture, if it warms very substantially, then actually the negative effects of climate change that we hear much more about in the media are actually dominate the positive ones. The other thing that you see in this picture is that experts really can't agree. The first impression that you get from this graph is that the impacts are just all over the place. Now that is a little bit misleading. The gray line that you see is essentially what we did there was we fitted 7 alternative functions that have been impact functions and have been proposed in the literature, fitted this and then used the fit to weigh them, and then the gray line that you're looking at is the Bayesian model average, the weighted average of these 7 different models. Now, if we use that gray line to scale everything to 2.5 degrees, this is the picture that emerges. And what you see is, yes, there is a lot of uncertainty, there's a lot of disagreement, but 60% of estimates says it's somewhere between 0 and -2. And that is a message that has been around since the second assessment report of the IPCC in 1995, that yes, climate change has an impact, a negative impact on human welfare, but it is actually fairly limited in size. This is not the story that you hear some politicians, particularly in Europe, say. This is definitely not the story that you hear activists tell. But this is what the academic literature says, that yes, there's negative impacts of climate change, but it's actually not that large. Recall that 2.5 degrees of warming is something that will happen over 60 to 80 years, right? Whereas 2 degrees of damage, that is a year of economic growth. If you're in China, it's a bit less than a year of economic growth. So far for the estimates of the total impact of climate change. Now let's look at the impacts of weather shocks. As I said, there's 11 studies that come in 2 groups. 7 papers estimate the impact of weather shocks on economic growth via the equation that you see here, that it's the level of the temperature that affects economic growth. And if you make that assumption, you see, and this is again on the horizontal axis, again, we're looking at scenarios of climate change and what would happen to the annual growth rates. And what you see on this vertical axis is very large numbers. And these are percent points, right? So essentially what this says is that 2 degrees of warming may knock off 2% of the growth rate. So instead of growing 5% per year, you grow 3% per year, right? That's how you need to read these numbers. So these are very large effects. There's strong disagreement between the estimates, but they are in general very, very large. Now, that may alarm you, or if you're a climate alarmist, you may use this information, as some people have, to argue for more stringent climate policy. There's 3 problems with this, these particular estimates. The first is that if you do a cross-validation test, if you actually use these models to forecast things that you excluded from your sample, then they don't pass the validation test. Also, if you run these models in a direct competition with the models that I will show you next, they also do not pass the econometric tests. But there's also a fundamental conceptual problem with this, because if the growth rate of the economy depends on the level of the temperature, the state of the climate, then if climate change would stop, then we're still at permanently elevated temperatures. You would still see permanently lower growth rates. And this, of course, flies in the face of everything we know about economic growth. And essentially, this is a new form of climate determinism. So both econometrically and conceptually, these models seem very peculiar. Another group of studies, only 4 of them, estimate the change in the economic growth rate as a function of the change in temperature. Again, you see strong differences between studies, but the most important thing is that if you focus on the vertical axis, the effects are now 2 orders of magnitude smaller. Instead of 1 degree of warming knocking off 2% of growth, you now knock off 0.02% of growth, which is much more reassuring. If we compare the weather studies to the climate studies that I talked about before, this is the picture that emerges in the large graph. Just show the true effects to the true size, but then you can't really see what is going on here. So in the small thing, I just curtailed the vertical axis, and you can see much better that the climate studies, which I here call comparative static, or the implied growth effects from the comparative statics, actually are not at all inconsistent with what we find in those econometric studies that look at the effect of temperature change on economic growth. The studies that look at the impact of weather shocks on the impact of weather on economic growth are essentially outliers in this literature. So that is roughly what we know about the total impact of climate change. Now, we're not really interested in the total. We're interested in optimal climate policy. And of course, we cannot take away the whole of climate change. The best we can hope for is change things a little bit at the margin. And therefore, we should turn our attention to the social cost of carbon, which is nothing else than the impact of emitting a little bit of extra CO2 into the atmosphere. Now, because this is a more economically relevant parameter, a more politically and policy relevant parameter, there have been many more papers on this. My count stopped at the 31st of December 2021, when 207 papers were published with a total of almost 6,000 estimates. And I won't take you through the whole thing. This is what we see if we plot these estimates against time. And you see some confusion in the first 20 years or so. This is Bill Nordhaus's first estimate, by the way, 1982. But from the year 2000 onwards, what we see is a steady increase in estimates of the social cost of carbon. And there's 2 reasons for this. And all of these have been normalized. This is all in real dollars. And this is all for for the same emission year. If we control and correct for these factors, we still see a steady increase in estimates of the social cost of carbon. And there's two reasons for this. One is that people have gradually shifted to lower discount rates, which of course matters a lot. But the other reason is that over time, people have become more concerned about climate change. And this increase seems to reflect a genuine increase in the estimates of the impacts of climate change. So that is something to keep in mind. Over the years, we have become more worried. Now, turning to the actual subject of today. I mentioned the discount rate already, and that is terribly important. If we take all these 6,000 estimates and turn them into a kernel density, then something like this, somewhat peculiar shape emerges. There are estimates, as I said, there are reasons to believe that climate change has positive effects as well. And some of these effects are very much in the near term. And it could well be that we should not be talking about the social cost of carbon, but about the social benefit of carbon. That actually we should not be taxing emissions, but according to Pigou, we should be subsidizing emissions. There's a small probability that that is the case. But by and large, people estimate that climate change is bad, not just in total, but also at the margin. And this is roughly the PDF, or this is the PDF that you could, the probability density function that you could draw on this. So that is one thing that you see. And the thing that you notice, of course, is that it has a fairly fat tail. Yes, there is a lot of concentration of probability mass for the lower numbers, for relatively modest carbon taxes, but we cannot exclude that it actually should be very large. I cut it off at $1,600 per ton of carbon here, but actually the tail just continues and continues and continues, and it's a bit unclear where it goes to zero exactly. We can talk about it at length later if you so wish. So that is one piece of information in this graph. The other piece of information is that I decomposed this probability density function into different estimates using different pure rates of time preference or utility discount rates. And that is what you see here. This is a 3% pure rate of time preference going all the way down to a 0% pure rate of time preference. And these 6 numbers that you see here have been regularly used in the literature. And what you see is that if you use a fairly high discount rate, 3% per year for utility, not for money, you don't see much of a right tail. Sorry. Whereas most of the right tail, apologies, most of the right tail that you see, most of the severe impacts of climate change are really due to estimates that use a fairly low discount rate. And this should not surprise you at all, right? Climate change mostly occurs in the future. The social cost of carbon is not just the marginal, but it's the marginal of a net present value. And the lower your discount rates, the more you care about the future, the more you care about the future, the more you care about climate change. And the more you care about climate change, the higher the social cost of carbon should be. And you see that emerging here, that the lower estimates are associated with a high discount rate and the higher estimates are associated with a low discount rate. And as I said, that partly explains this increase, but not fully explains this increase, because over the years, people have also shifted to a lower discount rate. So that takes me to the third chapter. And I need that to go into the actual topic of today. And that is how sensitive are these estimates of the social cost of carbon to what are not empirical parameters, but what are normative parameters? This is not positive economics, this is normative economics. And I'm going to talk about three of them, the discount rate, and the rate of risk aversion, and the rate of inequity aversion. And I'm going to step away from the meta-analyses that I've shown you so far, and instead focus on the results of one particular model that David Enthoff and I developed called FOND. And what you're looking at here is the sensitivity of the social cost of carbon on the vertical axis as a function of two parameters. One, in different colors, the utility discount rate, the rho, the pure rate of time preference. And on the horizontal axis, we plot the curvature of the utility function, the eta. Now, the 1928, Frank Ramsey published this paper towards a mathematical theory of savings, where he shows that the consumption discount rate, R, this is the rate at which we discount future money, depends on these three things. One is your utility discount rate, the pure rate of time preference, rho. The other is the growth rate of consumption, at what rate you become richer. And the third element is the curvature of the utility function, or the rate of relative risk aversion in the Arrow-Pratt sense of that word. And you see two things happening here. One is, as I said already, the higher the pure rate of time preference, the lower the social cost of carbon. You simply care less about the future, and you see that the green line lies above the blue line, lies above the brown line, right? Low discount rate, middle discount rate, high discount rate. So that is a fairly simple relationship. But then as you increase the curvature of the utility function from linear to logarithmic to even more curved, you also see that because the eta goes up, the discount rate goes up as well. You discount the future harder, and you see this monotonic decrease in this estimated social cost of carbon. So both the pure rate of time preference and the rate of risk aversion are important in this regard. And the social cost of carbon is fairly sensitive to this. I mean, it varies from 300 to practically zero, right? Now, this is without parametric uncertainty. If we take this model and assume that all its parameters are not known with certainty, but in fact, we assume a probability density function for this, and we run a big Monte Carlo analysis, and then estimate not the social cost of carbon, but the expected social cost of carbon, this picture emerges. You still see that the pure rate of time preference has a simple, intuitive, and unambiguous effect. That is, the pure rate of time preference goes down from the brown curve to the blue curve to the green curve. The social cost of carbon goes up, right? It's as simple as that. Also, for the eagle-eyed amongst you, for a linear utility function where the rate of risk aversion is zero, these numbers are actually identical to the ones that you saw before. But now if we increase the rate of risk aversion, two things happen. One, we discount the future harder. So the social cost of carbon comes down initially, but not nearly as fast as it used to do, because we now also put more and more weight on what is going on in the tails of the distribution rather than in the center of the distribution. And what you see is that if the rate of risk aversion gets high enough, the sort of risk aversion component of the curvature of the utility function start to dominate the intertemporal trade-off part of the effect of the curvature of the utility function. And you see indeed that the social cost of carbon goes up fairly rapidly. Of course, there's the dismal theorem that says by Marty Weissman that actually says it goes to infinity pretty quickly, and that is indeed what you see happening here. It just starts to skyrocket. So these two parameters, the pure rate of time preference and the rate of risk aversion, are terribly important for setting the social cost of carbon. And reasonable people can reasonably disagree on what is the appropriate value of these parameters. Now, the third element takes a little bit of an introduction. And so far, I've been talking about the global average impact of climate change, but the vulnerability to climate change is not at all equally distributed across the planet. So previously, I showed you this meta-analysis of the, 39 studies. There's a lot of regional variation in these studies. Some even have national variation or subnational variation in these estimates. And they can be used to estimate the impact not of climate change, not on global welfare, but on national average welfare. And that is what you see here on the vertical axis. We're still looking at the Higgsian equivalent variation. How much does 2.5 degrees of warming make you feel worse off? But now, instead of having scenarios of climate change, I just focus on the 2.5 degrees, and we're looking across the world, where the numbers that you see here, and notice that this is a logarithmic scale, is per capita income in the year 2015. So the rich countries are here, the poor countries are here, the middle income are somewhere in the middle. And what you see is a very clear pattern that the negative impacts are very much concentrated in poorer countries, whereas richer countries may actually see by and large positive impacts of climate change. And there's 3 fundamental reasons for this. First is that poorer countries have a larger share of their income in activities such as agriculture, and even larger share of their workforce in agriculture. And that means that they are directly exposed to the weather and the climate, whereas people like us who teach at universities, we sit indoors all the time and we're actually not that bothered by the weather. But if you're a farmer and out there, weather and climate matter a lot to you. So that is one reason poorer countries, because of the structure of their economy, are simply more exposed to weather and climate. The second reason is that poorer countries tend to be in hotter places. So this is the same information, but I changed the horizontal axis. Now it is the average temperature in the year 2015, or in the period 30 years until 2015. And what you see is that hotter places are much more vulnerable to climate change than are colder places. And actually the positive impacts of climate change are concentrated in currently cold places. Very intuitive. If you're already in a hot place, it gets hotter still, you're closer to your biophysical limits, and the plants and the animals on which you rely are much closer to the biophysical limits. And also in terms of adaptation, if you live in a place like Beijing and you wonder what would happen if it gets hotter, you look at how do people in Shanghai live their lives, right? And you have an immediate model on how to adapt your behavior and your technology and your institutions. Whereas if you live in one of the hottest places on the planet, Singapore, Dar es Salaam, Jacobabad, then there are no analogs, right? Your adaptations to climate change have to be invented from scratch because there's no hotter cities on the planet. The third reason that poorer countries are more vulnerable to climate change than richer countries is that a lot of adaptation to climate change depends on technology, on having sort of the technical wherewithal to protect yourself, having the economic means to buy these things. I talked about dike building before. Those things cost money and they require technology, and not everybody can pay for that, and not everybody knows how to do these things. But it also depends on having a capable government, a government that is willing to protect its people, a government that is able to levy the taxes to pay for protecting those people, and a government that is not too corrupt, that actually, when they collect taxes, they actually spend it on public goods rather than on Swiss bank accounts and big houses, townhouses in London town. And of course, lower adaptive capacity is essentially lower government quality, and this is one of the causes and consequences of underdevelopment, right? So there are structural reasons why poorer countries are more vulnerable to climate change than richer countries. Now, this matters because the global social cost of carbon is the aggregate of the national social cost of carbon. And what we're doing is we're adding up impacts across the world. And how we add up things actually is not at all trivial. So what you could do is use so-called equity weights. And they work as follows in theory and in practice. So what we have is national estimates of the total economic or the marginal economic impact of climate change, and they're given in dollar terms or in pound sterling or in renminbi or what have you. And then you need to make 3 transformations to get to a global estimate in, say, dollar terms. First, you need to translate how this monetary loss becomes a utility loss by multiplying with the marginal utility of consumption. Then you need to translate how this utility loss at a national scale translates into a global utility loss by multiplying with the first partial derivative of the global welfare function to national utility. And then you need to renormalize the whole thing because you want this expression in dollar terms rather than in welfare terms. And this term here is what would happen to global welfare if the Martians would come along and give us $1 additional to spend, right? So this is the marginal effect of the global budget constraint. Now, this seems to be a forbidding term. If you assume a constant relative rate of risk aversion type of utility function and you assume a utilitarian global welfare function, then this awkward expression here translates into this one that you see happening here, where you want to weigh, this is called an equity weight, your national impacts by this term here, where YW is the global average income and YC is the national average income. And eta is some parameter that is greater than 0. Of course, if eta is 0, then this thing drops out, right? So essentially for countries that are below the global average, you attach a greater weight to their impacts. Whereas countries that are above the global average, you attach a weight that is lower than 1. And essentially this corrects for the fact that $1 to a poor woman is not the same as $1 to a rich woman. That is essentially what this term says, and you correct for that. Now, if you apply this to the distribution of impacts across the world, and you calculate what are the implications for the social cost of carbon, this picture here emerges. Again, the effect of the pure rate of time preference is simple. If the pure rate of time preference goes up, social cost of carbon goes down, right? It's as simple as that. But the effect actually becomes ambiguous. What you see here is that if your eta increases, and that's again on the horizontal axis, at a certain point here, you start to put more and more weight on what is going on in poorer countries. And as I just said, poorer countries are much more vulnerable than richer countries. So that pushes up the social cost of carbon again. However, there's another effect going on, and that is you discount the future harder and harder and harder. And definitely, if you also use a high pure rate of time preference, you're putting your equity weights go up, your discount rate goes up. So you put more and more emphasis on what is going on in poor countries in the short run. And that is why I mentioned CO2 fertilization early on. CO2 is plant food. It helps agriculture, particularly in drought-stricken countries, and they are mostly poor. So putting more CO2 in the atmosphere in the short run is actually good for agriculture in poorer countries, and the PIGU tax becomes a PIGU subsidy. And that is what you see going on here. Now, this is without parametric uncertainty. If we then put parametric uncertainty back into play, I showed you this graph, showing you this graph, showing you this graph, actually in this order, this one first, then this one, then this one. If you put all three effects together, then yes, we're still putting a lot of emphasis on what is going on in poor countries in the short run, but we also put a lot of emphasis on the risks that are going on the right tail of our distribution. And you see that actually the social cost of carbon is a cost, it's never a benefit. And you also see just how sensitive these estimates are to these, what are essentially ethical choices, right? So that leaves me 15 minutes to actually return to my title. And that is, what would the social cost of carbon for China be? And recently, friends in China tell me that the authorities, the highest authorities in the country, have started to show an interest in the social cost of carbon. It seems to be mostly because the Americans are estimating a social cost of carbon, and therefore we must as well, rather than that it's an inherent interest. But nonetheless, there is some interest from the very highest levels in China to have a social cost of carbon for China. Now, there's a number of papers out there, well, not many, but there's a few papers out there that try to estimate the marginal impact in China. And this is, of course, feasible. Previously, I showed you the projected impact of 2.5 degrees of warming for all countries in the world. You can actually use the same methods of imputation and extrapolation and interpolation to portray these impacts on the grid. And that is what you see here. And you see that, yes, Africa is actually, and particularly tropical Africa, is very, very vulnerable. India is very, very vulnerable. But China is not invulnerable either. And then you can just add up these impacts to come up with a total impact estimate, and therefore also a marginal impact estimate for every country. Now, it's important to realize that the social cost of carbon is an absolute measure. It measures the total economic damages at the margin from emitting a little bit of extra CO2 into the atmosphere. And whenever you look at a total, what you're going to find is that bigger countries have larger impacts. So this graph here shows you a breakdown of the global social cost of carbon into its national components. And I just showed the biggest 25 countries. And lo and behold, India comes top because it's big. Right? Big place, lots of people, relatively sort of a lower middle income, but because they are not too rich, they're obviously fairly vulnerable, and it's a pretty hot place to start with. So India is very vulnerable to climate change, right? And because it's so big, it actually comes out top. And China, because its economy is so big, projected to grow bigger and bigger and bigger still, actually comes second, right? So this is the social cost of carbon of China, or the national cost of carbon of China. The third one is actually Ethiopia, which may come as a surprise, but Ethiopia is growing very rapidly in terms of its population, right? And not so rapidly in terms of its income. So remains poor, but is a very sizable chunk of the world population. And more so in the future. And you also see that actually the first developed country that pops up is at number 23. That's the United States. And really, if we go to a more nationalistic interpretation of climate policy, where instead of trying to do good for the whole world, we do good for our own country, we internalize the national externality, but not a global externality, then the US should impose a fairly small carbon tax, And China should impose a carbon tax that is much, much higher, right? But I don't think that this is correct at all. I don't think that because it's a global externality, the social cost of carbon should reflect the impact on the whole world, and not just the impact on our own country. How can we do this? Now, there's two ways forward, and one is easy and the other is much harder. What we have at the moment, I mean, I started with showing these impact estimates, the 39 plus 11 studies. No people from Asia were involved. This is all done by scholars in Europe and North America. Now, that is fine in a way, that's not so fine in other ways. It would be very good to have estimates of the economic impact of climate change done by Chinese scholars, just as a sanity check. This is not just a matter of political buy-in and representation, but there's also a lot of extrapolation going on. So I talked briefly about these enumerative methods, where essentially what you do is you estimate the number of people that died prematurely, and then you estimate something called the value of a statistical life, that is our willingness to pay to reduce the probability of dying prematurely. The estimates of the value of statistical life are all based on European studies. Another component in the impact estimates of climate change is how do we look at nature and how much do we care about species going extinct. And this is essentially based on studies done in the United States and studies done in the United Kingdom. And then these estimates are extrapolated to the rest of the world. So it would be really good for those reasons to have more estimates that are grounded in the behavior of people that live outside of Europe and North America. But this is a hard road. This is not something you can easily do. What you can do easily, and I have 10 minutes to do this, is that you can actually take the current estimates and wonder, can we come up with a social cost of carbon not based on Chinese estimates, but at least with Chinese characteristics? And that would be the question, what would Mao Zedong do and what would Confucius do? And I realized that I completely mispronounced their names. I mispronounce every Chinese name always. So I've given you the proper names as well. Now, one thing that at least we in Europe are being taught about Chinese culture is that it emphasizes patience and prudence, which translates into high risk aversion and a low discount rate. And in terms of patience, that is actually borne out by the data. What you're looking at here is estimates from the World Value Survey, and then expressed in Hofstede's long-term orientation indicator. And what you see is indeed that in China, people are much more oriented towards the long run than towards the short run. That is, they have a low discount rate compared to people in North America, right? So that seems to be borne out by the data. The thing of prudence is not borne out by the data. This is again Hofstede's, the World Value Survey. Actually see that China is actually quite risk-loving, quite tolerant of uncertainty compared to basically the rest of the world. So that is one piece of information. The other piece of information is this study by Riegel et al. That was published 8 years ago in Management Science, where they estimate the rate of risk aversion, the curvature of the utility function for people across the world. And China is actually in the 10th percentile. Actually, 90% of the world population is more risk averse than your average Chinese person. And there's another study that is intriguing in this sense, an information intervention. When people from China were sort of reminded of their Confucian heritage of prudence, they actually became more risk-loving. They actually actively resisted their Confucian heritage. Now that seems to bear out that people in China are more risk tolerant than people elsewhere. Another thing that, of course, communism, Marxism, Maoism emphasizes is an equal distribution, definitely of opportunity and preferably of outcome as well. It emphasizes the needy over the wealthy, and that is a higher rate of aversion to inequity than what you would see in other cultural and political systems. Now, the problem with, I mean, when I started doing this, I sort of went with the caricature of Chinese culture that you guys are all very prudent, right? And then there would be an unambiguous message, right? If you have a lower discount rate, you have a higher rate of risk aversion, and you have a higher rate of inequity aversion, then the social cost of carbon with Chinese characteristics is higher than a social cost of carbon with American characteristics, right? Unambiguously the case. But because of data, right, actually turns out that the rate of risk aversion in China is lower than in the rest of the world. The result is actually ambiguous. I would think that the discount rate is still the primary signal, and therefore I would argue that a social cost of carbon with Chinese characteristics is higher than one with American characteristics. But because of this risk aversion thing, I can't be sure of that. That's all I wanted to say. Thank you for your attention. These are the papers that I used. Over to you.
Thank you so much, sir, and so, for your presentation. And I have one question, or I want to ask for your view. And what insights policymakers in China can pull out of an estimate of the social cost of carbon to make to help them make better informed policy decisions?
Well, that's a simple and a hard question. So there's three things going on, right? First, should there be climate policy? Yes, there should be. That is simple enough, and I don't need to convince the Chinese authorities that there should be, because they have been convinced already. The second question is, should there be a different social cost of carbon in China than elsewhere? I don't think there should be, but it should be an informed discussion with the rest of the world about how high this thing should be. And that, of course, is not so much that we would like to harmonize the fiscal system across the world, right? That may be something that economists would like, but it's definitely not something that is politically feasible within the next century, probably a millennium. But I mean, what we see happening at the moment is a gradual realization in political circles that the targets that were set by the Paris Agreement of 2015 are infeasible, right? That we're not going to meet them. And that means that we would need to have, within a decade, we would need to have a grown-up discussion about what those targets should be, right? And then, of course, the issue of what is the appropriate intensity of climate policy is an important discussion, right? So those are the simple answers. Really, the way I see, because I told you how uncertain all these estimates are and how sensitive they are to particular parameters, but there's also a lot of other uncertainty about emissions, uncertainty about response of the climate system, and so on and so forth. I don't think we should see the social cost of carbon really as a prescription that this is the PQ text, this is what we should impose and we should all go home. But I see it as a way of disciplining the discussion about climate policy. What the impression that I get from climate policy and energy policy in China at the moment is that there is no such discipline, that there are a great many policies to do all sorts of things with the environment and do all sorts of things with the energy system, that these policies are not necessarily coordinated. There's so many initiatives. And also these policies are not coordinated between provinces and between the nation, right? And one prime example of that is you had this period where you had pilot systems of tradable permits, and then you introduced a national system, but for reasons that are completely beyond me, the pilot systems are still going, right?
Yes.
It's not quite what you would like. I would have liked to see the pilot system merge to a national system rather than seeing them continue. So I think what the authorities in China really need to get their head around is simple Beaumont and simple Tinbergen, right? That if you have a single problem, namely you have you emit too many greenhouse gases, is that you need a simple single policy intervention rather than putting policy intervention on top of another policy intervention on top of another policy intervention. And that, of course, leads you then to the Beaumont principle that really the cheapest way of achieving this goal is to equate the cost and the margin. That is, that companies and households face a uniform price, or whether that's an explicit price through tradable permits, or an explicit price through a tax, or an implicit price through regulation. That doesn't matter, but those prices should be equated throughout society and throughout the country. And that is most definitely not the case in China at the moment. So rather than talk about what would the appropriate price be, I would rather, if I were allowed to speak freely to your leaders, is to say, I'll make sure that everybody pays the same price. And let that be your starting point before you start worrying about what that price would be.
Thank you so much, Professor. And I agree with you that, this energy transition or energy decarbonization is not one single process. It's actually a multiple process that needs to be coordinated in a concert manner. And for that, we need policy coherence. What basically we need is that we need a coherent policy framework that can provide a guidance to actions in various areas where, those actions are going to decarbonize. In various sectors and so on. So that part I agree with you. But in your later comment, I may challenge that China has recently put in place something called 1+N+ framework, and that framework is basically that one is about principles, and that principles is about some guiding principles for specific policy instrument for driving decarbonization process in various economic sectors. So that 1+N framework basically provides some kind of coherent guidance, even though it's not perfect, but it's a good start.
No, that's good news.
Yes. And I think we have run out of time, and so I will have to wrap it up here. Thank you so much, Professor, for today's presentation, and it's very insightful. And again, more information about access activities are available from our website. And thank you again to Professor Richard Tong and our attendees. And we will see you next time.
Okay.
Just give me 1 second. Sorry.
Go ahead.
Rita, thank you very much. It's a great presentation. It's a very interesting topic. I think I'm pretty surprised to see that there's no Chinese scholars that would try to estimate the social cost of carbon. But I think that's a good direction for people actually trying to work on. I think a lot of Chinese audience today. I think that's one thing we should learn from this presentation, trying to add some Chinese characteristics and get some numbers that is comparable to those extrapolations from the Western studies. By the way,
actually, before you ask your question, one point of correction: there are Chinese estimates of the social cost of carbon, just not of the total impact of climate change.
Oh,
so essentially, they take the first partial derivative of Nordhaus's work, right?
Okay, all right, okay. But anyhow, it's a kind of good direction. We should probably, yeah, just like looking from the Chinese side and see what's going to happen. You know, where there's kind of differences. But it's a big gap actually from two sides. Yeah. Well, but just one more thing for thing that we are you happy because we are recording this video and we are going to share that in our share this dialogue on our website. Are you happy with that?
Absolutely.
Okay, yeah. Your permission. Because I think there's a bit of problem because I think it's kind of messed up about the schedule. So I think some of the people may not be able to get into this this talk today. But so we would like to distribute this information. But thank you very much. It's a great pleasure to hear from you, and hopefully we could catch up soon.
Yes. Okay.
Thank you so much, and thank you for everyone for attending this session, and we will see you next time. Thanks.
Okay. Take care, guys.
Bye. Bye, Richard. Thank you.